This tutorial is going to look at the draft and the shell feature in Creo. So I've created this part as an example of the sort of part that you might use both of these features on. So this is essentially a what could be a molded plastic box, maybe for storing food in, that you might create using injection molding. So maybe this would be a plastic, maybe polypropylene or something, polyethylene, and you made it using the injection molding technique. And most likely what you would do is you would machine an aluminium mold out of two pieces of aluminium, and one piece of aluminium would fit inside this shape here, so it would be essentially a protrusion, and the other half of the mold would have an indent in the mold that would surround this side of the part. And then when the molding was complete, the mold would split probably around this top surface here, and half of the mold would go off in this direction, and the part would be left stuck to this half of the mold on the left hand side. But the part would come off this half of the mold quite easily, because this part has been given walls which have an angle on them. So the angle allows you to remove this part from the mold quite easily. Whereas if this side here, if these upright surfaces on our part were at 90 degrees, they could grip slightly onto this half of the molding tool, and it would be hard to remove them. You would need some pins pushing quite hard to get them off. So that method of putting a slight angle on your upright faces is known as a draft angle, and there's a tool in Creo to allow you to add draft angles to existing geometry. And then if we look at the shell tool allows you to create a 3D solid and then to turn that solid into a thin walled feature. So we'll have a look at these two tools now. We'll try and recreate an approximation of this part. So if you'd like to create a new file, give your file a relevant file name so that you can save it to your working directory. And then what we're going to do to begin with is we're going to sketch on the top plane. So we're roughly going to sketch out the perimeter size of our container. So we'll just quickly sketch a rectangle. We'll hit the dimension key and give it some suitable dimensions. If we're not entirely sure at this point, then we could maybe drag some of the edges. There we go. Maybe drag it to the approximate sizes that we want, and then maybe just tighten up on those sizes with some actual values that we type in. So there's the size of our perimeter of our part, and then we'll just create a rough extrude there, give that a specific number. So that's essentially the broad outline of our part. So what we're going to do now is we're going to apply a draft to this part, and the way that we're going to do that is we're going to select the draft tool, and then if we open up references again, this feature is trying to draw our attention to this first tab, this references tab, which is why it's highlighted in red. You can see that the first box that it requires some entry into is the draft surfaces box, and what this is going to be, I'm going to select the draft surfaces from this part. It's going to be the faces on this part that need to be angled in order to provide the draft on this part that will allow us to remove it from a mould. So it's these surrounding surfaces here. If we were to look at the original part there, we can see that it's these upright faces that require draft angle. So that is what we're selecting now, the faces that require some draft angle on them. So the next one down, draft hinges. This is essentially the edges that represent the point that these faces hinge about. So in our case it will be all these edges around the bottom of the part. So there's a few ways that we can select these. We could hold down Control and select all 4 of them if we wanted, or we could drop into details here, go to rule based and select complete loop, and then if we select one edge you can see that it then pre-selects all the edges that form a loop starting at the edge that we selected. So we'll OK that. Then what we need in this bottom box is a pull direction. So this is essentially a face or a reference that tells the system in what direction are the 2 halves of our mould going to move away from each other. So we could select one of the planes, or we could select a flat surface. We're going to select this bottom surface, and you can see that we get an arrow indicating the direction of pull, and we also get a preview. It's quite hard to see the angle that's been created there, but if we zoom in you can see that this line represents where the face was, and this line here represents where the face will be once we apply the draft angle to it. So if we want to make that effect a little bit more pronounced, we can enter a higher draft angle here. Currently it's at 1 degree. If we put something like 4 degrees in there, you can see all the faces jump outwards to 4 degrees. And again we can vary this using the drag handles if we want, and you can see what effect that is having. So let's put it back to 4 degrees and OK that. So we've now applied some draft to our base shape there. What I did next to achieve the finished article that we looked at originally there is I added some round features, and it's fairly important that if you are going to add rounds to a feature that you're then going to use the shell tool on, it's fairly advisable to add the rounds before you use the shell, and the reasons for that will become obvious once we've done it. So let's add some round features. Let's add them to all these drafted edges that have been created here. So I'm holding down Control while I'm selecting these edges so that they all get added to the same round set. If you don't hold down Control, the system will create new sets for each one, and then when you come to vary this value here, you won't be able to affect all 4 edges. You'll only be able to affect the one that you're editing. So let's enter a number in there, say 15, and then when we've done that we're going to put a new round on here as well. So you see I just selected one of the edges, and because all these edges are tangent to each other, it's happy to assume that I mean all the tangent edges. And again we'll put maybe a 15 on there, maybe a little bit less, maybe a 10, and then we'll OK that as well. So that's our basic shape. The only thing that we need now is we need to scoop out some of this material on the inside, or the majority of this material, and just leave the part as this outside surface, and then a wall of a certain thickness, and then a corresponding inside surface. And the easy way to do that is to use the shell tool. Here's the shell tool up here, just below the draft tool, if we select the shell tool, it's not immediately obvious what we are required to enter. You can see that there's a thickness entry box here that has a predefined value in, but if we click on references, we can see that it's asking for removed surfaces. So in our case, if we look at the other part, you can see that the main difference is that this top surface now has gone. So it's fair to assume that if we select the top surface, you can see that we get a preview of a part where the original top surface has been deleted and all the material has been deleted from the inside of the part, and then a new wall has been created that is this thickness value. So you can see if we increase that thickness value, the wall increases in thickness. So with a moulded part, something of the order of 2 mil would be reasonable. And then if we OK that, we can see that we've essentially completed our part. So the shell tool will hollow out a part down to a wall thickness that you specify, and the draft tool will add some angle to certain faces, and the thought behind that is that it will make it easier to remove the part from a mold tool if you have to mold a part using some form of former half of the mold.